So, trying to make sure that we're actually live here before I start lecturing. I just did one for a little while and it wasn't actually showing my screen. So I just want to double check that. And then as soon as I get everything sorted out, we'll get started. So if you just bear with me for a second, we'll get everything going. Start talking about generator functions. Okay, so we are live. That's good. Next thing I want to do is share the window that I got going on here. So let me make these some separate windows. So I'll go ahead and share a window and we'll share this one. All right. So hopefully that pops up here in a second. There it is. Here's the generator functions window. Let's make sure that pops up. All right, so if you're watching, welcome. We're going to talk about generator functions in JavaScript. And if you can hear me okay, and you can also see my GitHub repo right here, then let me know in the comments. If you can't see anything or you can't hear me okay, please be sure and let me know, because I don't want to do another entire live stream and you not be able to see it. So again, if you can hear me okay and you can see my window, just let me know in the comments below. We're going to go ahead and get started. So today we are talking about, well, before I get started, real quick, the live stream software that I'm using is from Opus. They got me in a beta program right here. We're just trying it out. It's actually pretty awesome. Great support from the team over there. And if you're doing live streaming in any capacity, I totally recommend that you check it out and see if it's right for you. So that's opus.pro, opus.pro. All right, so getting on with the lecture. We're talking about generator functions in JavaScript. If you haven't heard of them, you're going to learn all about them. And if you have heard about them, maybe you'll learn something new. So let's start with what generator functions are. And so here we have a brief description about what they are. Basically, they're just like a regular function, except different. Now, they're a special kind of function where we can yield information in sequence. And we're essentially giving control over how that information or data is consumed to the program or whoever wrote the program. Or if you wrote the program in such a way that there's a UI interface where the user can click something and then you can disseminate the data to them. That way you're controlling when information is passed along instead of just having it given to you as the moment the function gets invoked. So if that doesn't make sense, don't worry, we're going to dive deep. So you're going to get some exposure and you're going to figure out what the heck these are all about. Just to get started, if you want to write your very first generator function and get back a generator object, then you'll use the function keyword just like you would if you were writing a function in JavaScript, except instead of just writing function, you're going to use an asterisk at the end of the function keyword. And then instead of using the return keyword to return something from the function, you're going to use the yield keyword. And so what yield does is it returns a value, but it also pauses the execution. And that's really important, and we're going to see why. So in this example here, we have that function keyword with the asterisk, and then we have the name of the function. So this is just a regular named function, except it's got the asterisk. So now it's a named function that's pointing to a generator object. So we call this one count generator, and we say let count is equal to 0. So we're just initializing a variable called count, and it's block scoped to this function. So if this function has these curly brackets, that makes this a closure. And this count variable is agnostic of any count variables that are defined outside of the function. Okay, so here we say count is equal to 0, and then we have a loop, and we're just saying while true, which is like what? An infinite loop, right? Not necessarily something you would normally want to do. While true, yield the count. So yield the variable count, whatever its value is, and then increment the count by 1. So we just get that plus plus operator. It's basically saying count is equal to itself plus 1, or count plus equals 1. Okay, so let's see how that works. Well, if we create a variable called count, mind you, this is not the same variable that we have up here, even though it looks very similar. And we say let count equal to, here's this count generator function, and we invoke it, and the return value is a generator object. So now count is pointing to that generator object, and by default, the generator object that gets created is suspended, meaning it's paused essentially. And so the way that we get it to resume is by calling .next. So .next is a method that every iterable object has to have on it. These generator objects have them by default. And so do things like arrays and strings. But if you want to make something like a regular object, like an object literal, into a iterable object, then you have to go and customize that object to have this special method, and it has to return an object with a special set of properties. In this case, one of those properties is called value. So when we call count.next, it returns an object to us, and it gives us a property called value. What is value? Value is super important because it points to whatever was yielded, right? And so in this case, we have an infinite loop that yields over and over and over again. Well, the beauty of these generator functions is that we're not getting an infinite sequence of numbers. We are, but we're only getting them one at a time, and we control when we get back each value for each iteration of that loop. Mind you, not every generator function uses a loop. In this case, we're using a loop as an example, but you could do it differently. We can give you an example of that before this is all over. So in this case, every time you call count.next, you get this object with the value property, and the value is equal to whatever was yielded at the time that the function was called. So initially, count is equal to 0. You do the count.next.value, and you get back 0. Now, count is plus plus, meaning count is 0 plus 1. Now, count is equal to 1. And so if you do a count.next to the next iteration, the next yield, then you get the value of 1. And so you just keep repeating that pattern, and you get 2, 3, 4, 5, 6. You could go to infinity, right? And beyond. So that is, in a nutshell, how you create a simple generator function. Okay, there's a bunch of other implementations of it, and we'll go over some here in a second, but that's just in a nutshell. The main thing is when you create it, like when you're doing the function definition, make sure that you use the asterisk on the function keyword, and then make sure, so once it's created and you invoke the function, you assign its return value to a variable, what you have there is a generator object, okay? And so then you can call .next on that object. You can also loop over it depending on how you structured the code inside your original functions. We'll get into that in a minute. So let's, real quick, before we get out of this slide or out of this section of the documentation, let's talk about a real-world use case for generator functions. So one of those is implementing infinite scrolling on a web page. So imagine you have a social media feed with 200 or 2,000 or 2 million posts that need to be displayed. And as you're scrolling down, they're popping up 10 or 20 at a time. So you only want to give 10 or 20 at a time. You don't want to load all 2,000 of them and then like kind of make them appear 20 at a time. You want to just give what you need, what the program needs. And so that is it's great for infinite scrolling. It's great for lazy loading. It's just a great way to manage how you're consuming data in a memory efficient way. So that's one potential use case. All right, so let's go back to the index here. If you're going through this repo, the README is where we are. It has links to everything. If there's anything that you don't know term-wise, check the glossary. I might have a link to either the documentation or to some resource that I created. So for instance, the two-dimensional array, which we're going to talk about in a second, has its own resource, and so is transpose, whereas all these other ones are links to the documentation. So if you want to learn more about generator functions on MDN, Mozilla Developer Network, just click on this one. It'll take you over here, and you can go through, gives you code examples, gives you explanations. Same thing for the yield keyword and for what the generator object is and what the iteration protocols are, inheritance and prototype change. So these are all things that if you go through all these learning objectives, you may have questions about. So let's go ahead and dive right into this first learning objective. And basically, we're going to use a generator function. So this is just a quick overview of everything we just talked about, to take in a multi-dimensional array, in this case, a two-dimensional array or a matrix, and we're going to transpose it. So if you're not familiar with any of these concepts, please don't worry. I'm going to explain all of them. But we're going to transpose it, and then we're going to iterate over it and return the values of that sequence in row first order. Excuse me. Let's go ahead and see an example of what that is. So I'll open up the console here, get rid of all that junk, and let's say we have a two-dimensional array. So what that means is you have a regular array, and instead of just having one dimension of elements inside of it, you have nested arrays. So this is the second dimension. So you can have as many of these as you want, and for them to be rectangular, they all have to have the same number of elements. So we'll do a really simple 2x2 matrix here. So 1, 2 in the first nested array, and then 3, 4. The values aren't important. I'm just putting them in sequence because it's easier for our brains to understand, or mine anyway. So here you've got this outer array with two arrays inside of it. And just looking at it, it still looks kind of like linear and one-dimensional. So if we put it on two lines, now all of a sudden it looks a little more like a matrix, if you're familiar with that concept from math. But basically a table, right? We have rows and we have columns. So here on our first row, we have 1 and 2 in the first column, the second column. And then in the second row, we have 3 and 4 in the first column, the second column. Okay, so a transpose of this, if we put a line diagonal through the 1 and the 4, and we just flip the entire thing over that line, 180 degrees, that's the transpose. So what we're talking about with a transpose is the 1 would stay where it is, the 3 would switch with the 2, and then the 2, of course, is now in place of the 3, and the 4 stays where it is. And if I take that back, there. So this is the transpose. And if you'll notice the pattern here, what happened was we had a row 1, 2, and then we had another row 3, 4. And what happened was the row 1, 2 is now the first column. The first row is the first column. It got flipped. In this case, the row got rotated, right, from a row to a column. And so we have 1, 2, but instead of being horizontal in a row, it's in a column vertical. So 1, 2, and then 3, 4. So the second row, 3, 4, becomes the second column. If my little whatever dance moves there help you understand it better. Okay, so that's what we're doing here. In this case, we just want to write a generator function that can take in a two-dimensional array, like anything like this. It could have more values, doesn't matter. Transpose it, and then go in row first order. So first element in the first row, second element in the second row, all the way to the last element or column in that row, and then goes down to the next row. And we want to output the values that are in there. Okay, so you can do this with regular JavaScript, or you can do it, not that a generator function isn't regular JavaScript. What I mean to say is you can do this with like an array data type, right? You can transpose it, put the new values into an array, and return the array. Great. But what we want to do is we want to yield the information, yield the values of this sequence back to us as a generator object so that we have more control over how we consume that information. Okay. So here's the code example. Function uses the asterisk. So now we know we're dealing with a generator function. And we call the function transpose generator, and it takes in a argument of array. So the parameter there is ARR. The first thing we do is we use a traditional for loop to loop over not the array length, but the length of the first element in the array. So if we have an array with arrays inside of it and they're all length of 3, that makes it a rectangular, two-dimensional rectangular list or array. List is like a Python term, but interchangeable with array. And I use them interchangeably in this markdown file. So we want to iterate over the total length of any one of the rows. Because all the rows have to have the same length in order for them to fit into the definition of a two-dimensional rectangular array, we don't care which one it is, so we just go ahead and go with the first one at index 0. So we're iterating over that, and then on the next one, we want to iterate over the total number of rows of the outer array. The outer array is what holds all these nested arrays. So we're like, how many nested arrays do you have? That's how many iterations we want for this inner loop. And what that does is it allows us to go column by column, row by row, and deal with each one of those values. So we say, hey, the first value is here and it belongs there. Second value is there and it belongs here, and then print it in sequence. And so once we get down into the nested for loop, we have the yielding of the row that we're on and the iterator, so the column that we're on from that row. And so we'll go ahead and get into the code so you can see an example of this. But like, let's say the output is a two-dimensional array. In this case, it's a 3-column by 2-row or a 2-row by 3-column, two-dimensional array, rectangular array, and the rows are 1, 2, 3, and then 6, 5, 4. Kind of weird, hard to wrap your head around, but that was the example I was given when I was asked to teach this. I'll give you another example. It's a little bit easier to digest here in a second. So you can see that we've created this transpose generator function, and we use it inside this for of loop. So for of is just a really handy way to iterate over anything that is iterable, meaning it follows the iteration protocol, meaning an array of elements or a string that has characters or a map, or in this case, a generator object. Okay, you can use objects too. It's not by default, but if you want to use objects with let of or for let of, or just for of, you have to do some additional stuff to it. You can use for in with an object, and that's a whole nother thing, a whole nother topic. But if you want to use an object with for of, you have to add some additional properties to it to make it abide by the iteration protocol. I have a link to the iteration protocols back in the index, the README file of this entire lecture repository. Feel free to dive into that if you want to learn more. Okay, so here we have 2 rows, and we're saying for let element of transpose generator array. So what's happening here? What's happening is transpose generator takes in this 2-dimensional array and does the thing. And inside of it, at the very core, it yields each element in row first sequence after it's been transposed. And so what we're saying here in our code is just log those elements in the sequence that you yield them back to us. Okay, so if we have 1, 2, 3, 6, 5, 4, and we transpose that rectangular array or list, then what we get back if we go in row first order is 1, 6, 2, and then 5, 3, 4. Originally it was 1, 2, 3, and then 6, 5, 4. Now it's 1, and then it goes down to 6, and then back up to 2, and then down to 5, and then up to 3, and then down to 4. It's not actually zigzagging like that. What it does is it transposes them first. It flips all of these elements on their diagonal axis, and then it goes through in row first order and gives them back to us. So we could look at that particular example, but it's a little confusing. So what we're going to do is we're going to do a simpler one. All right, so here we have our function, transpose generator, and we're going to follow the same pattern where we use the for const elements, or I'll just call it L for brevity, of, and then here we can pass in the transpose generator with an argument. That way we don't have to assign this to a variable or anything like that. And then here we're just going to console.log the element. Okay. And so the transpose generator can take an array, but it has nested arrays inside of it. And in order to make it a rectangular list, you can, as long as the nested elements or the nested arrays are of the same length, then you have a rectangular list. So I'm actually going to make a square list. It's a rectangular list, but a rectangle is a square. So it's a little bit easier. And I'm going to put the values in order so that you can see once the rows become the columns and the columns become the rows because of the transposition, if that's even a word, you'll be able to more easily identify the pattern. So let's say 1, 2, 3, and then the second one, them in sequence, 4, 5, 6, and then the third row, 7, 8, 9. Now, mind you, this is kind of a linear, one-dimensional looking thing, even though it's not. And so in order to kind of mitigate that and make it more obvious that we're dealing with the matrix, I'm going to restructure it. So now if you look at it, it's 3 rows, 3 columns. First row, 1, 2, 3, second row, 4, 5, 6, 7, third row, 7, 8, 9. So what's going to happen is on the axis, everything's going to get flipped. So the 2 and the 4 are going to get flipped, and the 3 and the 7 are going to get flipped. The 5 stays in the same place, and the 8 and the 6 are going to get flipped, and the 9 stays in the same place. So what you end up with is 1, 4, 7, 2, 5, 8, 3, 6, 9. Okay. Just to give you a visual of that before we invoke this whole thing. It's going to be 1. The 1 stays where it is. And then the 2 switches places with the 4. And then the 3 switches places with the 7. And then on the next line, we have the 2, which switch places with the 4. The 5 stayed in the same place. The 1, the 5, and the 9 all stay in the same place because that's the axis, right? So everything on either side of it is what gets folded over 180 degrees. So the 6 switches places with the 8. And then the 7 already switched places with the 3. We said the 6 switched places with the 8. So we have 6 here and we have 9. And so if you look at this, what's the pattern here? It was row 1, 2, 3. But now that row has flipped over the axis, has rotated 90 degrees, and has become a column. So we, instead of having 1, 2, 3 horizontally, we have 1, 2, 3 in the first column. Instead of having 4, 5, 6 in the second row, we have 4, 5, 6 in the second column. And likewise, instead of having 7, 8, 9 in the last and third row, we have 7, 8, 9 in the last and third column. That's what transposing is. And then what we do is we go over it. This is the transposition here. That, again, I don't know if that's a real word, but this is the result of transposing that matrix. And we're just going to go row first. That's what the algorithm calls for. Iterate over it and yield us these values in row first sequence. And so we're going to go through and say, give me 1, give me 4, give me 7, give me 2, give me 5, give me 8, give me 3, give me 6, give me 9. Okay, so if I get rid of that and I run this, assuming I haven't done anything wrong, then what we get back is the 1, the 4, the 7, the 2, the 5, the 8, the 3, the 6, the 9. And that is the yielded sequence. Okay, so that is how you use a generator function. Note that for every yield, we are yielding a value every time .next is called in our generator object. So we didn't really get into that, so let me show you an example of that so you can kind of understand like the pure power and beauty of generator functions. After that, I'll just give you kind of a brief conclusion and show you some of the other learning objectives if you want to go through those on your own. If you have any comments or questions or anything, obviously feel free to ask me. Hopefully you learned something. But before we go, let's delve into writing generator functions just a little bit more. So again, if we want to write a generator function, we just do function asterisk, and then we'll do something like, it doesn't even matter. So we'll say hello. Okay, doesn't take in any type of argument. And check this out. Before we had the very first example, if you remember, we had while true. That was our infinite loop. Really scary, right? And we were able to control each iteration getting back the value one at a time. We didn't run that code, but we saw it happening in the example code. And then here we did the transposed generator that takes in the two-dimensional array and gives us back the values of the transposed array in sequence. Great. That's a mouthful. You may or may not have been able to follow it all, but let's do something. Let's back it up, reel it in, and do something a little bit simpler. Okay, so the yield keyword, this is like where the power is with these generator functions. So again, instead of return, we say yield, and then we yield anything we want, right? Any primitive data type, any data type that we want. So we can say hello. Go to semicolon on there just to make JavaScript happy. We can say yield world, okay? And then yield, doesn't matter, anything you want. This could be a number, right? It could be an object. All right, so that's our generator function. 3 yield keywords. What the heck? So if we go over here and we create a variable, so let's say let greet is equal to say hello, and we invoke it. And then we take a look at greet, you can see, even without clicking enter, that we have a say hello object or function that's suspended, meaning it's waiting for us to tell it what to do. And so if we call .next, it's going to give us back an object. And this is what the iteration protocol is all about. If you write a custom object that has a next method that returns an object with a value property and a done property set to a Boolean, then you are following. There's one other thing. You have to use like a symbol, something or other. It's in the documentation that I've linked. But there's a couple things you have to follow to make your object iterable, and some built-in data types like the array and the map and the string already have the iterable iteration protocols built into them. Okay, so in this case, this is a generator object and it has it built in. So it gives us the .next on this instance of say hello. So when we say greet.next, it says, hey, there's the string hello. And so if we had assigned the result of greet.next to a variable, then we could have said .value. Or if we had chained .value onto this, we would have gotten back hello. In this case, we get back the whole object, and that's fine. If we could do it again, what do you think we get next? We get world, the string. So we can actually just call it directly. So we get greet.next.value gives us world. Now, if it had given us the whole object, if we hadn't appended the .value property and gotten this value property from the object that it returns, that .next returns, then we would have seen that done is still false. And done remains false until everything is done being yielded. And then the value becomes undefined and done becomes true. In the example where we had the infinite loop, it would never become done true because it was running infinitely. And the value would never be undefined because it's always incrementing to the next value. We just stop calling it when we want to stop calling it. It stays in limbo. It's not a problem, right? We're not taking up a bunch of space in memory or anything like that. So if we run it one more time, what do you think the expected output is? 100,000. There it is. And this one's a number data type. So it's just powerful, right? This is great because we can control how we consume this data. We can either call .next and get it when we want it, when we need it, or if we need to get it all at once, we can iterate over it with for of. And here's the other thing I'll show you in a second. You don't have to get it all at once. And that's the whole, going back to the concept of like a lazy loading or an infinite scroll, is that we don't want all of that information at once. Maybe we want 10 posts at a time or 10 images at a time. So we have full control over what we get back and how we consume that. So if we do it one more time, next value is undefined. And if we check .done, we're actually doing it another time. It doesn't matter. Once you get to undefined and true, it's just going to keep giving you the same object over and over again. It's like, hey, this thing's done. And so what that does is if you have a for of construct, you're running a loop with for of on something that's iterable, and it gets to the point where it's returning no value, the value is undefined, and that the done property is true, then it knows, okay, there's nothing that I need to return from this loop. We're done looping. Okay, we can continue on with the rest of the program. So let's go here. Because we used the let keyword, we can just say greet to overwrite the greet variable with this object starting fresh. So now it's resuspended and we start all the way back at the top of the yield. We'll call it a yield chain. That's not actually what it's called. But if you start at the top, the first thing we're going to get back with .next is hello. I don't want to do it manually. I want it all to arrive back to back to back programmatically. Okay. So to do that, we're going to say for const val, short for value, of, and then we have greet, which is our generator object. And then here we're going to console.log the val and close that. And what do you think we're going to get back? Hello world 100,000. There it is. Oh, and don't forget the undefined at the very end, right? So there's our loop. Hello world. Those are both strings, and then 100,000. That's that number. Now, last thing we're going to do here is we're going to create a loop with a finite number of loops. We're not going to do an infinite loop, and although you could do an infinite loop, and we're only going to consume a certain amount of values at a time. Okay, so let's start fresh. Again, function, asterisk. Now we're writing a generator function, and we're going to call this get posts. Okay. Now, you could be making an API call to whatever database to get all the posts. On the back end, you could have some pagination set up. There's all kinds of different configurations and implementations here. But in this case, we're just going to pretend that like we're looping over a finite number of posts. Okay. So we're going to say for, we'll just do a traditional for loop. Let I is equal to 0. I is less than, say, 100. And then I plus plus. Okay. And then here, we're just going to yield I. Easy. Okay. You can put this on multiple lines if you want. I'm just trying to keep it simple. All right. So basically, it's going to iterate 100 times from 0 to 99, and it's going to give us I. So I is going to start at 0. If we want, we can say I plus 1, just so it starts from 1 and goes to 100. Okay. So that's get post. Now, if we say let post is equal to get, not get compute style, get post, and we invoke it, post is now pointing to the get post object here that is suspended. It's waiting for us to decide how we want to consume it, right? So yeah, you could do .next.val or .value, and you could get back 1, and you could do it again. You could get back 2, or you could do a loop, and you could get back 1 to 100, bam, 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 all in a row. But here's where it's really powerful. So let's do for let I is equal to 0, I is less than 10, I plus plus. And then, let me make sure I'm doing this right. Post. Doing that right? Get post. That is going to be iterable. Go ahead and throw a console.log in there. Post_value. And I'm curious if it's post_value or if it's post.value. We'll run it one time and see what happens. Okay, so then like that. Post.value. Okay. And undefined. Something is not right. So if we do the for const, or we'll use let val of post, and then we console.log the val, what we're going to get back is 1 through 100. Okay. And now post is done. If you look at post, you can see it's actually closed. It was suspended, now it's closed. If you do a post.next, it actually gives you value undefined untrue. So what I'm trying to figure out here, and I'm like blanking on the syntax. This is the second time I'm doing this video, so my brain is a little bit washed from looking at the screen for the last like 2 hours. But if you bear with me for a second, I'm going to try and figure out how to consume the value. And I think I just figured it out. Yeah. Okay, so what we're going to do is we're going to reassign posts to get posts. We can't use the post variable with the let keyword because we've already assigned it using let, but we can't override it because let is overridable in this context or in this scope. So now we have get post. It's rebooted. It's giving you a brand new generator object, and it's waiting for you to call .next. And that is the key, the ticker. So here, what we want to do is post.next.value, and we're going to log that. Now notice we're supposed to get 100, right? The generator function loops 100 times. In this case, we're only telling it to do it 10 times. So we're getting the first 10. So in your code, you can say, give me the first 10. There's 1 through 10. Now, if you run the same exact code again, it's looping from 0 to 10, right? Is it going to give you the first 10 all over again? No, it gives you the next 10 in line. So it gives you 11 to 20. And likewise, you can just keep repeating that pattern. Every time we run this loop, we are controlling what it gives us back. We're saying, give us the next in this case 10, but the next in elements inside of this generator object that are being yielded. And that's the beauty of it, right? We just created kind of a quasi little pagination here where we controlled what values we got back in what sequence, what timing, etc. So if you have a user that's on a web page and they're scrolling down, and every time JavaScript identifies that the scroll bar has reached the bottom of the page, it goes to this generator function and says, run this loop and give me 10 more of the resource, whatever it is, the Instagram post, the Twitter feed post, the Facebook post, etc. So generator functions, super powerful. And we learned a little bit about matrices and some cool math stuff, right? Transposing of a two-dimensional matrix. So if you go back to the index here, again, I've got a glossary of information here. about the things that we've covered. We didn't talk about the inheritance and prototype chain. We're going on pretty long here, so I'll have to save that for a different video. Just know that if you, just like in short, without me actually showing you, but just to put it in your head, if you use for of on an object, you have to first modify that object to follow the iteration protocols. And if you use for in, which is a different type of construct for looping over an object, what happens is you use the in operator, and the in operator actually will include any properties on a object that are included in the prototype chain, which may not be what you want. So that's why I have inheritance and prototype chain, so that if you use for in and you realize that gotcha, you can go look that stuff up. Now, there are solutions for using for in without getting access to the inherited properties from the prototype chain, and that would be doing things like using object that has own property to make sure that the property belongs to that specific object and not something on the prototype chain. And there's one other way that I can't think of off the top of my head. But anyway, that's for a different lecture. In terms of learning objectives, if you want to test yourself on everything we've just learned, we have 2 more learning objectives here. Transform a list into pairwise sums of contiguous entries. I know that's a mouthful, but if you break it down, it's really simple. And then find 2 consecutive entries in a list that sum to a specified value. Again, it's another mouthful, but it's simple stuff. And if you go read through these, you'll get a clear explanation of exactly what's expected and how to do it. So maybe like block off the bottom part with the solution and first just look at the prompt and see if you can do it. In any event, I may go over those in a future video, but thank you for spending time with me, or if you're watching the replay of this, thanks for taking the time to watch this. If you like this video, please give it a like and share it. That helps with the algorithm and all that good stuff. And again, before we go, we're using Opus. It is a streaming software, cloud-based. Really neat stuff. They reached out to me and gave me a little demo. That's what we're using here. And so far, it's worked really good. So thanks, Opus. Check them out, opus.pro, and we'll catch you all in the next video. Thanks a lot.